Today we discuss the numerical of physical geology 2024 to 15. The first question is from 2015. A radioactive isotope has 1024 atoms. How many atoms will remain after 4 half-lives? After 4 half-lives, that means you have given n equal to 4. Number of half-lives is 4. It has this much of atom, that means n0 it is given 1024. So we can apply the formula half to the power n equal to n by n0. So half to the power 4 is equal to n by if we solve this, then n will be 64 atoms. Next question is from 2018. The crustal rock is at lithostatic pressure of 3 kilobar at a temperature of 275 degrees centigrade. So this is the surface. So a crustal rock will at some depth it will have, suppose this is the rock, it is at 3 kilobar pressure and at a temperature of 275 degrees centigrade. So the lithostatic pressure, the gradient it is given, it is increasing at a uniform rate of 0.3 kilobar per kilometer. Then 0.3 kilobar per kilometer. So now we can calculate the depth. From this we can calculate the depth. From surface to this much of depth, it is expressing 3 kilobar. So, and the gradient it is 0.3. The pressure gradient it is given 0.3 kilobar per kilometer. So if it is increasing 0.3 bar per kilometer, then at what kilometer depth it will have 3 kilobar pressure. First we have to calculate the depth of the crustal rock. The pressure increasing 0.3 kilobar per kilometer. So 1 kilobar it will be 1 by 0.3 kilometer. Then for 3 kilobar will be 1 by 0.3 into 3 kilometer. It will be 10 kilometer. So that means the depth of the crustal rock it is 10 kilometer. So at 10 kilometer depth, it has a temperature of 270 degrees centigrade. It has a temperature of 270 degrees centigrade. So we have to calculate the geothermal gradient, it is per degree per kilometer. So crustal surface temperature it is given 25 degrees centigrade. So as it go downward, it is experiencing 275 degree temperature here. So that means up to this depth, it has already 25 degrees centigrade. So we have to calculate how much is increasing from 25 to 275. So at surface it was 25 degree. Now at this depth, after 10 kilometer depth, the temperature is 275 degree centigrade. So there is an increase of 250 degree centigrade temperature from surface to the depth. The surface to depth, there is an increase of 250 degree centigrade of temperature. So the gradient, geothermal gradient will be geothermal gradient will be 250 degree divided by 25. Sorry, 250 degree by 10 kilometers. So it will be 25 degree per kilometer. So geothermal gradient will be 25 degree per kilometer. So that means in 10 kilometer it is increased 250 degree. So the gradient will be to 25 degree per kilometer. Answer will be 25 degree per kilometer. This was another question of 2018. The number of alpha particle emitted to produce daughter element of PB206 of a parent isotope of uranium-238. So uranium-238, when it will decay to PB206. So number of alpha particle, it can be calculated from the difference mass number. So always remember, number of alpha particle, it can be calculated from the difference the mass number. It will be difference in mass number divided by 4. So difference in mass number will be 32 divided by 4 will be 8. So the number of alpha particle emitted will be 8 during the conversion of uranium-238 to 206. So the intensity of an earthquake of magnitude 8 on Richter scale, then the intensity of an earthquake of magnitude 5 on the same scale. So you know the amplitude or the intensity increases 10 times when the magnitude is increased by 1. Magnitude is increased by 1. So that means here you can calculate the change in magnitude, or at what times the magnitude will intensity will change. The 10 to the power difference in 10 to the power difference in magnitude. It will be 10 to the power 3. Will be 1000 times. Will be 1000 times. So intensity at 8 will be 1000 times more than the intensity at 5. So in an ocean basin, a 4 million year old oceanic crust lies 40 km away from the ridge axis. So this is your ridge axis. In an ocean basin, a 4 million year old oceanic crust, it lies 40 km. Suppose this is 40 km. Here there is the crustal part which is 4 million year age. It is 40 km away from the mid-oceanic ridge. So what is the average velocity in centimeter per year in oceanic ridge? So this crustal part, before it were at the axis, when after formation it gradually move away from the mid-oceanic axis. So you can calculate the velocity of plate so 4 million years divided by 40 kilometers, because it takes 4 million years to cover 40 kilometer distance. So we have time, that is 4 million years. We have distance, that is 40 kilometers. So we can calculate the velocity, so we expecting which is 4 million years, 4 into 10 to the power 6 year. So it will be 40 kilometer by 4 million years, distance by time. Relative distance by time 40 kilometer divided by 4 million years. So 40 kilometer into 40 into 10 to the power 5 centimeter divided by 4 into 10 to the power 6 year. So it will be 1 centimeter per year. The radius of Earth's circular orbit around the Sun, it is given. Radius of Earth, it is given 1. Radius of Earth's circular orbit, it is given 149 into 10 to the power 6 kilometer. The Earth takes 365 days to orbit the Sun. So T is given. T is given 365 days. Now I have to calculate the tangential velocity. So tangential velocity, calculate 2 pi r by t. So 2 into pi is given 3.14. R is 149 into 10 to the power 6 kilometer. You have to calculate kilometer per hour. So 365 days will be 24. 365 into 24 hours. It will be 106817.35 kilometer per hour. A P wave arrives at the mantle core boundary at an angle 25 degrees. Suppose this is your mantle core boundary. So P wave, it arrives the mantle core boundary at an angle 25 degrees. So 25 degrees. So then, so this is the incident angle. So you can say I equal to 25 degree here. At what angle to the normal does it enter to the core? So that means this refracted angle is asked at what angle it will enter into the core. That is R is asked. So given the P wave velocity in the lower mantle is 13.7, it is here then 13.7 kilometer per second. And sorry, this 8. This is your 13.7 kilometer per second. This is the lower mantle, and this is the outer core. It is given 8.1 kilometer per second. So sin I by sin R will be equal to V1 by V2, 13.7 kilometer per second divided by 8.1 kilometer per. So sin 25 divided by sin R will be equal to approximately 1.6913. Then sin R will be sin 25 divided by 1.6913. Will be 0.24987. If you take sin inverse, then R will be sin inverse 0.24987 to 14.47. Only 14.470, round up it into 2 decimal. That will be 14. The mass of the Earth is 80 times the Moon. We'll take the mass of the Earth as capital M, which is 80 times the mass of Moon. Then the radius of the Earth, it is 4 times the radius of Moon. You have to calculate the surface gravity, how much times of the Moon. So surface gravity G of Earth we can calculate by G m by r square. Then G m will be for moon, it will be 80 m. So you can put 80 m in place of m divided by 4 r square. It will be 5 G small m by r square. So G small m by r square we can call it as cavity of moon. So it will be 5 times. So the surface gravity of Earth is 5 times that of the moon. So the amplitude at a station for magnitude 5 earthquake is x. The amplitude recorded in the station of magnitude 5 earthquake is x. If another earthquake recorded at the same station has an amplitude of 15x, then calculate the magnitude of the earthquake is dash. So first we will see magnitude given, it is 5. Take that m b, it is 5. Another earthquake recorded at the same station has an amplitude of 15x. Then the magnitude of that. So we have to calculate the magnitude of the another earthquake. That will take ma, because the amplitude here in second earthquake is more. So magnitude of the second earthquake will be more than the magnitude of the first earthquake. So intensity 1 is given, we'll take Ia, it is given x, sorry, Ib, it is given x, and Ia, it is given 15x. So there is a formula, equal Ma minus Mb equal to log Ia by Ib. So we have to find out Mb is given 5 divided by log 15x divided by x. We solve this, log 15, calculate the value of log, will be equal to 5 plus 1.179, will be 6.176. We have to round up to 2 decimal, that is 6.18. The answer will be 6.18. The magnitude of this earthquake will be 6.18. So geothermal gradient in the continental crust is 0.02 degree per kilometer. So it is given the geothermal gradient. Geothermal gradient is given 0.02 degree centigrade per meter. The surface temperature it is given 25 degree. They have to calculate the temperature at a depth of 18 km from the surface. So you have to calculate the temperature at the depth of 18 km from the surface. The surface temperature is 25 degree. You have to calculate the temperature here. So the gradient is 0.2 degree per meter. Per meter it is increasing 0.02 degree. So what will be the temperature at 18 km depth? So as 18 km depth, the temperature will be 0.02 degree per meter into 18 km. 0.02 into 18 into 10 to the power 3 will be meter, and meter will cancel, will be degree centigrade. with 360 degrees centigrade. So from surface to 18 kilometer depth, the temperature will increase 360 degrees centigrade. And the surface temperature was 25 degree. So the total temperature at this depth will be 360 plus 25, 385 degrees centigrade. This comes to 2 mark question. First question is the half-life of the radionuclide A is double that of the radionuclide B. A and B are two substances. The half-life of radionuclide A is double that of radionuclide B. If the half-life of radionuclide A is X, then for T half in X it will be 2X. The fraction remaining when B is reduced to 1 by 64. Sorry, the fraction remaining A, fraction of A remaining when B is reduced to 1 by 64. When B is reduced to 1 by 64, what fraction will remain in A? First we'll see what number of half-lives required to reduce B to 1 by 64. You know, half to the power n equal to 1 by 64, we can calculate 1 by 64. So half to the power n is equal to 1 by 2 to the power 6. So n equal to 6. So B requires 6 number of half-lives to reduce to 1 by 60. Now we have a relation that T half, it is in case of A, it is double of B. So that is relationship n equal to T by T half. Where the number of half-lives, it is inversely proportional to T half. If A half-life is double of B, then its number of half-lives will half than B. So B is the half-life 6 hochi, B is the number of half-life 6, then A is 3. So if n is equal to 6, then in case of number of half-lives, it will be half. So if the half-life is double, the number of half-life will be half. So here in case of A, n will be 3, then half to the power n equal to calculate after 3, it will be 0.125. The temperature of the Earth's surface is 25 degree centigrade. The temperature at the base of the Earth crust is at 30 kilometer thick. If the geothermal gradients are 25 degree centigrade per kilometer up to 15 kilometer depth and 15 degree centigrade per kilometer further down. It is given 25 degree centigrade at the surface. So you have to calculate the temperature below a depth of 30 kilometers. Geothermal gradient, it is given up to 15 kilometer depth. It is given 25 degree centigrade per kilometer. Then rest, it is given 15 degree centigrade per kilometer. First we have to calculate for 15 kilometer depth. First up to 15 kilometer depth, the temperature will be 25 into 15 centigrade. So 375 degree centigrade up to this much depth. This much of depth it is 375 degrees centigrade. Then again up to you can say from 15 kilometer to 30 kilometer depth. So that is 15 and 15 into 15 degrees centigrade will be 225 degree centigrade. So at surface it was 25, then up to this much depth temperature was 375, then up for this depth it increased 2 to 5. So total temperature will be, so temperature at 30 kilometer depth will be 25 plus 375 plus 2 to 5. Will be 6 to 5 degrees centigrade. As the base, the temperature will be 6 to 5 degrees centigrade. The two localities A and B on a continental plate, as shown in the figure below, are separated by a distance of 80 km. So there are two localities of a continental plate, they are separated by 80 km. The plate velocity is measured at A, it is 4 cm per year, at A it is 4 cm per year, and at B it is 5 cm per year. So assuming no faulting in the area, the new distance between A and B will be dash kilometer in 1 billion years. First we'll see at what distance or what much distance they will travel in 1 billion years. So they are traveling, suppose for plate A, velocity of plate A is 4 cm per year. So per year it is traveling 4 centimeters. So after 1 million years, how much distance it will travel? So we can calculate distance of A. This will take distance of A from A to A dash. There is A dash. It will be 4 centimeter per year into 1 million years. 4 into 10 to the 6 centimeter will be 40 kilometers. Will travel 40 kilometers. So A dash will be 40 kilometers. Then similarly, you can calculate the B dash. It will be 50 kilometers. So B travel 50 kilometers in 1 million years. A travel 40 kilometers in 1 million years. See, this is how much is that B plate is advanced from A plate. This is 10 kilometers. This distance will be 10 kilometers. So we have to calculate A dash, B dash. So what is the new distance between them? This will be 10 kilometers. This line it is parallel to A, B. So it will be also 80 kilometers. This line is also will be 80 kilometers. This 80 kilometers. So now this is 10 kilometers. This will be a right angle triangle. So we can calculate by using Pythagoras theorem. That is A dash B dash will be 80 square plus 10 square root of. It will be 80.6225. So you have to give answer in 2 decimals. So you write down 80.62. So new distance for A dash B dash it will be 80.60. So age of the granitic rocks can be determined by this formula. For a suite of representing 4 magnetic granitic rock, the rubidium, strontium, whole rock isochrone plot and relative data are shown in the diagram. This is the isochrone line. So we have to calculate the age of granite So this is a plot for granite rock, granitic rock. We have to calculate the age of the granite. Slope here is given. This is 0.0143. So for isochron method, tan theta is equal to e to the power lambda t minus 1. We are given 0.014301 tan theta. Then we have given lambda also 1.42 into 10 to the power minus 11 here inverse. Then you have to calculate the t. You have to calculate t minus 1. Okay. So this is equation. It will be 1.014307 e to the power 1.42 into 10 to the power minus 11 here inverse into t. So you will change the side, it will become ln 1.014307 divided by 1.42 into 10 to the power minus 11 here inverse will be t. So t will be so if you solve this, it will be 1 into 10 to the power 11 year. If you convert it into billion year, it will be 0.01. It will be 0.01 into 10 to the power 11 year. If you convert it into billion year, it will be 1 billion year. So it is as 1 giga year. Same thing. So the answer will be approximately 1 giga year. Assuming the Earth to be ideal sphere, the volume percentage of core related to the volume of the Earth. So this is Earth, this is core. So we can calculate the volume. These are the two volumes. The radius of the Earth, it is 6371 kilometers, and the radius of core, if you take, will be 6371 minus 2900 kilometers. It will be 3471 kilometers. Now two radius, you can calculate the volume percentage of the. So the volume, total volume of Earth will be 4/3 pi r cube. Volume of core will be 4/3 pi. Volume fraction will be, or volume percentage, it will be volume of core divided by total volume into 100. The volume of core, it is given 4/3 pi RT cube divided by 4/3 pi R cube into 100. So 4/3 pi will cancel each other. Then it is given 3471 the cube divided by 6371 the Q into 100. Should be 16.171 percentage. You have to you have to give answer in one decimal. 16.1%. In the given diagram, we have given 6 km high plateau. H is given 6 km. You have to calculate the root thickness. So root, it will be rho c into h divided by rho a minus rho c. So rho c crust, the density of the crust, rho c it is given 2800 kg per meter cube. Then rho m it is given 3100 kg per meter cube. So root will be 2800 into 6 km divided by 3100 minus 2800. They all have same unit. We cancel each other. The kilometer will remain. If you solve this, it will be 56 km. So the root will be 56 km. If the activity of a radioactive mineral falls from 800 count per second to 500 count per second, they are given activity A0 is 800 counts per second. A is given 500 counts per second. So T is given 80 minutes. You have to calculate the half-life of the mineral. So we can calculate by using this formula. Half the power n is equal to A by A0. So A by A0 will be 500 by 800. We'll take ln on both sides. N ln 0.5 equal to ln, it will be 0.625. The n will be ln 0.625 divided by ln 0.5. So n will be 0.678. So n we know it is t by t half equal to 0.678. So t is given 80 minutes divided by 0.678 will be your t half. So t half will be 117.994. So we have to round up into two decimal. It will be 118. This much minute. Next time proceed using array hypothesis, calculate the thickness of the root beneath a 4 km high mountain. Again, h is given 4 km. So rho c it is given 2800 kg per meter cube. Then rho m it is given 3300 kg per meter cube. You have to calculate the root r. The rho c into h, that is 2800 into 4 divided by 3300 minus 2800. So we have 22.4 kilometers. Then assume that polonium 218 with a half-life of 138 days. We will take P half A for polonium. We'll take P. We have P is given 138 days. This is secular equilibrium with the uranium 238, which is half-life T half of uranium. It is given 4.5 into 10 to the power 9 year. So how many grams of uranium, polonium 28? That means NP will take to calculate will be placing for each gram of uranium 238. And uranium will 1. For 1 gram, what will be the value of polonium? So they are in secular equilibrium with each other. So you can write down the equation lambda P NP is equal to lambda U NP. So lambda P you can write down 0.693 by T half T into NP. Then lambda U is 0.693 divided by T half U. And U is given 1. Then we can calculate 0.693 to cancel. So NP it will be P half P, that is given 138 days divided by uranium, it is given 4.5 into 10 to the power 9 year. So I have to convert it into days. It will be 365 days. The NP will be 1 gram. The NP will be 8.401 into 10 to the power minus 11. This much will be NP. But we have to express our answer to logarithmic base 10. So we'll take the log of the answer. So answer is 8 point this much. We'll express the answer in log 8.401 into 10 to the power minus 11. So it will be minus 10.3. It will be minus 10.07. So answer will be minus 10.07. Then comes to the ND 143, 144 and SM 147, 144 ratio, it is given 0.516, 0.389 respectively. The rock evolved as a closed system as per the exact parent-daughter relationship equation. The ND 143 by ND 144 ratio of the rock 4.6 into 10 to the 9 year ago was dex. It is as the initial ratio of ND 143 ND 144. So I have to write up the equation. ND 143 divided by ND 144 are present is equal to ND 143 divided by ND 144 at time 0 or initial plus SM 147 divided by ND 144 into e to the power lambda t minus 1. Here lambda is given, t is also given, this present ratio it is given 0. This is given 0.516, this is given 0.383, this one, this is given 0.389. So you have to calculate this one. Lambda is given 6.54 into 10 to the power minus 12 year inverse, and T is given 4.6 into 10 to the power 9 years. If you put this value in the equation, it will be, if you put this value, then it will be 0.516 plus x. We have to calculate this ND143 by ND144 at initial time plus 0.389, it is the same 147 by ND144, e to the power 6.54 into 10 to the minus 12, year inverse into 4.6 into 10 to the power year. So year inverse here will, they will cancel each other. Then here minus 12, 9, it will minus 10 to the minus 3. If we simplify it, the answer will be 0.502. So x will be 0.502 or 503 approximately. That will be the answer. So during calculation, calculate these things separately. It will be easier. Then the fraction of sodium atoms remaining after decay interval of 5 hours will be dash. So T is given 5 hours, T half it is given 15 hours. So N will be 5 by 15. So the fraction of substance remaining, it can be calculated by this up to the power N. That will be the fraction of substance remaining up to the power N equal to 1 by 3. So it will be 0.7955. So you have to round up to 3 decimal. It will be 6.80. Sorry, 796. 0.796. So this will be your answer.